So it looks like I am the warm-up band for these illustrious people. So if I start singing up here, no throwing of beer bottles at me. Okay, so these talks are supposed to be reasonably short, and so I thought I'd talk about dark matter. But the problem was, that's way too short. So since I really love watching the sky, and a lot of school kids recently lost their favorite planet, so I thought about talking about what led up to this decision here. And to do that, we got to start with the Greeks. Now, in spite of their limited technology, they actually knew a lot about the world. They knew that the Earth was round. They knew actually the diameter of the Earth. They observed that the positions of the stars were fixed relative to each other. In fact, they even gave groupings of them names. They knew that the stars went around once in the sky, once a little bit less than 24 hours. They also noticed that there were things wandering up there in these stars, which they considered to be perfect and unchanging. So those are the stars. But they noticed a few things wandering up there. In particular, the sun and the moon were wandering up there. But there were also other things wandering around up there as well. So we have a couple things wandering amongst the fixed stars. Okay, we're ready for a quiz here. Okay, so imagine you are in Athens in 300 BC. You're a student studying the planets. Which one of these planets, which one of these objects would not be listed in your textbook as a planet? Okay, you got it? So first off, you can't see Uranus and Neptune with the naked eye. And of course, the Earth is the center of the universe, so it's not a planet. So these are the 7 original planets. The definition of planets is wanderers among the fixed stars. The fact that there's 7 of them and that there's 7 days of the week, there's no coincidence there. They also noticed that Mercury and Venus were always near the sun, rising just before it in the morning or setting just after it in the evening. And they noticed that Mars, Jupiter, and Saturn went through what's called retrograde motion, going forward, then going backwards, and then going forward again. So, being human as they are, they came up with a model to try to describe their observations and to make predictions. And this was finalized, come on, big guy, finalized by Ptolemy. And it's actually a pretty cool model. It's not correct, but it's a pretty cool model. So they had the planets going around a circle, and then that circle is what orbited around the Earth. So that took care of your retrograde motion for Mars and Jupiter. And if you line the circles up with the sun, that takes care of Mercury and Venus as well. They entertained a sun-centered model, but rejected it because the Earth can't possibly be moving. And even if it was, the moon could not possibly be orbiting something that's orbiting something else. But in particular, they couldn't observe parallax. So a nearby star would move relative to the distant stars, depending on what side of the sun the Earth was on. That actually happens, but you can't see it with the naked eye. So that's why they rejected the sun-centered model. The problem with the Ptolemy model, though, was it was not good at predicting what they actually observed, particularly important dates. So that's probably why Copernicus revisited it 1,500 years later, revisited the sun-centered model. And it was not pretty warmly accepted, but there are a lot of holes starting to get blown into the Ptolemy model. So first off, both Tycho Brahe and Johannes Kepler noticed stars suddenly appearing in the sky, which we now know are supernova. The stars could change. But what really supported Copernicus's model was the invention of the telescope. Now, instead of spying on his neighbors, Galileo built his to look at the planets. And he found 4 moons hanging around Jupiter. The planets could have moons orbiting them. And he also found that Venus had phases, full phases, just like the moon does. The Ptolemy model predicted that Venus could only have a crescent phase at the most. So here's our first big demotion. So we've got wanderers as our planets becoming planets or things that orbit the sun. Now, if you think it's tough losing Pluto, imagine your home being demoted, being the center of the universe, to just being a planet. So as the telescopes got better and better, they were able to see more dim things up in the sky. And William Herschel, who was just cataloging the stars, noticed something moving up there. Found Uranus in 1781. Then in 1801, Giuseppe Piazzi was also cataloging the stars, and he found our 8th planet. So everybody say it with me. Sirius. So we've got our 7 planets, and he found our 8th one is Sirius. Okay, except in 1802, they found another one. These guys were hanging out between Mars and Jupiter. Then they found another one in 1804 and another one in 1807. By 1850, they had found 7 more. And if you looked at the textbooks in 1850, they would list that there were 18 planets. Try and imagine memorizing all of those names for class. Well, over the next 50 years, they actually found hundreds more, and they found that they were little dinky rocky things. So here's our second big demotion. We've got, with no outcry from the public whatsoever, we got these guys going from being planets to asteroids. There's over 200,000 known asteroids at this point. Well, in the 1800s, they got this really cool, shiny new math, and they were able to predict what the planets should be doing. And Uranus was not doing what it was supposed to be doing, so they figured there must be something big out there tugging on it. And sure enough, they looked around and discovered Neptune. They calculated right where it should be and found it right away. So here we are, back up to 8 planets. Now, I just want to point out that this picture is a little bit misleading. First off, the sizes of the planets are all off. So here's a better comparison of what they actually are relative to each other. And here's what they look like compared to the sun. Also, the spacing is way off. So I've always thought it would be cool to build a scale model of the solar system on campus. So if we did that, we'd have to make the sun half the size of a basketball in order to make it fit. We would just barely get the first 4 planets in this auditorium. Mars would be out there, and Earth would be the width of a pencil. We would have Saturn and Jupiter just on either side of Meldrum, the size of marbles, and Neptune would just barely squeeze in. So we're talking really big distances here. In 1906, Percival Lowell did calculations on Neptune's orbit and he decided there must be something big out there tugging on Neptune as well. So he did the calculations to look at where it would be. 24 years, they never found it. Then Clyde Tombaugh used a technique of taking a photograph of the sky one night and then again at a later night and comparing them and trying to find what's different. And finally, they found something moving up there. So they immediately announced, we got a new planet, we got this guy Pluto. Now, as they got to know Pluto a little bit better, they found it was definitely an odd duck. Most of the planet orbits are pretty much circular, but Pluto's is really elongated and actually is sometimes inside Neptune. The planets are all in the same plane, but Pluto's is tilted by almost 20 degrees off of the plane. And this thing, once they got to know how big it was and what its mass was, they found it wasn't very big. This was just a little dinky ice ball. Couldn't possibly be affecting Neptune. Turns out Lowell's calculations were all wrong, and it was just a nasty coincidence that they found it where they thought it should be. So, nothing else out there, so they just ignored the fact that it did not fit in. Probably shouldn't have been a planet. And this worked until 1992, when Jane Liu at Harvard University was looking for the source of a particular type of comet. And she found out, past Neptune, something out there. Over the next 10 years, they found hundreds more. These were all ice balls, but they were a lot smaller than Pluto was, so no need to panic yet. Until 2000. They found Varuna, which is still smaller than Pluto, but it's getting there. Time to panic. Then in 2002, Mike Brown at Caltech found a bunch of big objects, one right after the other, including one that was actually bigger than Pluto. So Eris, the goddess of discord and strife. Okay. So it is time to panic. It is time to admit the inevitable. So this is our third big demotion. So just like Sirius is one of many rocky objects in the asteroid belt, Pluto is just one of many icy objects out in what we call the Kuiper Belt. So, what happened to Pluto? Nothing happened to Pluto, but an awful lot happened to our knowledge of the universe and the solar system. Scientists work in terms of concepts, and so trying to define a word like planet is really problematic. You lose the richness of the concept. So if you imagine I'm a traveler from a different star and I'm coming to visit your sun, as you get closer, as I get closer to your sun, I notice these big, important objects. As I get even closer, I notice other different but equally as important objects. It's not till I get really close that I notice all these icy objects hanging together, and then all these rocky objects hanging together. So, is Pluto a planet? I don't think that's the best question. I think is, how did this come to be the way it is? This is the big, important question. Why is our solar system looking like this? I wouldn't classify Pluto as one of these important objects. But, you know, I think Pluto would be okay with that. I think Pluto is happy now. Okay. Thank you very much.